Okay, ladies, we have a couple of other short things to talk about for your notes today. This topic is called average, or it's talking about the difference between the average and the instantaneous. Average versus instantaneous rates of change. Now, I touched on that just a little bit in the notes on velocity and acceleration, so let me just make it a more general comment now, okay? If you're looking at any particular function, just make, there's our function that we're looking at, and we look at two specific points on that function, point A and point B. How fast is this function changing? It relates to the slope of the line or the slope of the curve, which means the slope of the tangent line of the curve, which means the derivative. Okay? So if I ask you for the instantaneous, I'll do this in red, the instantaneous rate of change at A or at B, what we're talking about is the slope of those lines that I've written, shown right there. So the instantaneous rate of change at A is a larger number, positive, than the instantaneous rate of change at B. You would get that by finding the derivative, okay? On the other hand, the average rate of change from A to B is the slope of the line that connects A to B. It's just basically y2 minus y1 over x2 minus x1. You don't need to take a derivative for average rate of change, okay? So one of the things that people do most often is they see this word average and they get all excited and they want to add things up and divide, but that's not how you do it, okay? You do average rate of change by y2 minus y1 over x2 minus x1, just by doing the slope of those two lines. Okay, let's do an example. Nice little polynomial. Okay, nice easy derivative. All right. If I ask you to find the average rate of change of f from, well, sometimes they say from x equals to x equals, but often they'll give you the interval on 1 to 2. Okay? All right, so average rate of change does not mean add them up. It means y2 minus y1 over x2 minus x1. Your best bet on this notation is to stick with your function notation and tell me what you're doing. F2 minus F1 over 2 minus 1, my x vectors. Okay? Show as much or as little work after that as you need to. And the average rate of change is 19. Okay? That's the average rate of change. All right? Compared to, find the instantaneous rate of change at x equals 1 and then at x equals 2. Two different answers. Okay? So this question, instantaneous rate of change, is telling you to find the derivative and plug in whatever number that you've been asked to plug in. So this sort of corresponds to, if you're, I think I used this on the velocity one, if you drive from here to DC, and it's about 120 miles, and it takes you 2 hours, then your average speed is 60 miles an hour. And at some point during that drive, you were going 60 miles per hour, but you also sometimes went 45, or you slowed down to 20, or you sped up to 65. So the instantaneous rate of change is how fast you're going right now, or how is anything changing? How is any function changing right now, right at this specific point? And the average is just regular slope, y2 minus y1 over x2 minus x1. So you just plug these two into the derivative that was given above, a little further up. Okay? So that was generic. You can do that with any function that you can take. You can take its derivative, or you can put numbers into it. You can handle it. Okay? So sometimes we are set into some sort of context problem. So suppose you have something called a cost function, which is a function that tells you the cost. And I'll say y equals c, and c is a function of q, and q represents order size, how many you're going to order. Okay, so this is a context question. All right, so let's look at some questions you might be asked. You might be asked to find the cost when 200 items are ordered. And you find the cost when 200 items are ordered. And so what you would do is you would take the cost function and you plug in 200. Okay, and you would find that answer. All right, you might be asked to find the cost when 201 items are ordered. In which case you would take the cost function and you would plug in 201 to get a different answer. Okay? Another question you might be asked is, what is the change in cost when the order size for the Q increases from 200 to 201? What is the change in cost when Q increases from 200 to 201? Well, that is asking you to take the cost of 201 and subtract from it the cost at 200. These are just all questions that might come about. Okay? You might be asked to find the average rate of change of the cost from Q equals 200 to Q equals 201. Sometimes that's wrapped in a little bit of language, but you can usually pull that out pretty easily. It's not usually very hard. Okay, so what's this asking you to do? This is the average rate of change. So this wants you to do the cost at 201 minus the cost of 200 over 201 minus 200. This is y2 minus y1 over x2 minus x1. This is just slope. Okay, average rate of change is just find the slope. And then finally, you might be asked to find the instantaneous rate of change of C, C, and then given a specific Q value when Q equals 200 or when Q equals 201. And that would be take the derivative of the cost and plug in 200. Take the derivative of the cost and plug in 201. So I don't think this part is very difficult. I think what makes some of these problems difficult is the actual function that's given to you. If the function's easy for you to take the derivative and easy for you to plug numbers in, this is all pretty easy. But if they give you some kind of wonky function, then you have to be a little more careful with arithmetic. The good news is that if they give you some kind of wonky function, you're usually able to use your calculator to actually get your answers. Remember that you do know how to plug a function into y1 and then go back to the home screen. And if I ask you to plug in 200, you type y1 parentheses 200 and hit equals, and it will act like a function. And you can also use the derivative of y1. I think it looks like this now, 200, and you can do that. But just make sure that you're writing, don't write this notation and don't write this notation. Make sure on your work you actually write C of 200 and C prime of 200. But then you can get your calculator to help you with it. Okay, so that's general rates of change versus average, instantaneous rates of change versus average rates of change. Okay, the second little mini topic is just a note about the general rates of change. It's all about rates of change. Okay? If I give you that V equals S cubed, I tell you that S is in feet. This is actually the volume of a cube. Okay? when we start asking about rates of change, they're going to get a little bit more complex. If I just say, what's the rate of change? And that's all it says, nothing else, then it means dv ds. It means whatever the two variables are that are there. So that would just be 3s squared. Okay, that's all it says. But more and more, you're going to have to take the rate of change, which is the derivative, with respect to, is everybody okay with that? With respect to time. With respect to time, and so I'm going to use t for time. Right? Then that means I'm asking you to take the derivative with respect to time of v, and take the derivative with respect to time of s cubed, taking the derivative of both sides. So usually we just write this one as dv dt, and the next is chain rule, because I've got the variable here is s, but I'm taking the derivative with respect to time. So I get 3s squared, and then what do I have to put on the end of that? ds dt. So in order to find how the volume is changing with respect to time, I need to know how the side is changing with respect to time. Okay? So if I ask you to find volume when s equals 2, I want you to write on your paper what you're doing. Volume when s equals 2. Plug that in. I don't care if you show me the arithmetic for that. You don't have to write 2 cubed on your paper. That's okay, but make sure that you're telling me in function notation or other appropriate notation what you're doing, and make sure that this is a context problem, that you have units on the answer. Okay? If I ask you to find the rate of change of volume with respect to s when s equals 2. I'm going to use the other notation here. My volume is not particularly written in function form, so you can use function notation for that. That's fine. But I'm going to use the other notation here. I'm asking you to find the rate of change. That means dv ds, and then you draw that line, and you say when s equals 2, and I want to see that notation. And then you don't have to actually show, I never got actually taken the derivative, have I? Okay, did I take the derivative? Oh yes, I did. 3s squared, that's the top. So you can show this if you want to, that's okay, but you can also do that part ahead, and the answer would be 12. And you need to make sure you know what the units are, okay? It's the units of volume divided by the units of the side. So the volume is feet cubed, and the side is feet. Please don't reduce that, because then it makes no sense. You're maybe thinking, doesn't make any sense now. Volume changes by 12 cubic feet every time the side changes by a foot. That's what that's telling you. The volume changes its cubic feet change as the length of the side changes. So don't reduce that. Leave it in exactly that form. Okay? This means that the volume is increasing because it's positive, because the rate of change is positive. It's increasing by 12 feet cubed for every, if you wanted to think, one right there, for every 1 foot increase in the length of the side. 1 foot increase, in the length of the side. Okay. All right. Another little tidbit that you're supposed to know, but if you're like me, you've forgotten, and it's this word proportional. If I make the statement A is proportional to B, I'm telling you that A is equal to some constant times B. You don't have to use a K, you can use C, but a lot of people use K. And sometimes you'll see this written instead of A is equal to something proportional to B. Sometimes you'll see it written as K is equal to the ratio of A to B. That's okay, but this is really the sort of direct translation this, all right? If I say A is inversely proportional to B, A is inversely proportional to B, A is K divided by B, okay, divided by B, and sometimes you will see this written as K equals AB. I would stick to one or the other because if you, as you can see, they both have a form in multiplication and a form in division, and you can get a little bit confused if you're not paying real close attention. So I try to stick to the first one. When they're proportional up here, this one, as B increases, A increases. As B decreases, A increases, decreases. And when they're inversely proportional, as B goes up, A goes down, or as B goes down, A goes up. So it's reversed, okay? And one other one, A is proportional to the difference between B1 and B2. Okay, so I'm going to start with this part. A is proportional to. A is proportional to. A equals A times something. Okay, and what is it proportional to? It's proportional to the difference between B1 and B2, and that goes just like this. There you have your statement. Okay, all right. And for any of these, the reason I'm giving you these is they show up in some of your homework tonight, and you have to get the first statement right in order to do the second statement, which might involve saying something about taking the derivative of this. Okay? It's also possible that you'll see one that says this. The rate of change of A is proportional, or it might say inversely, to B. The rate of change of A is proportional to B. So we're going to start with this. The rate of change of A DADT is proportional to B. Is proportional to B. All right? And I have to go back and make a correction because I just realized I said something wrong. Way back, where was that? I think it was no, I don't think I said it at all. So let me go back here and say this. This is back over at the beginning. If someone just asks you to find the rate of change, this is it. This is where I make the mistake. When someone just asks you to find the rate of change and they don't tell you what it's with respect to, it's almost always with respect to time, not to the given variables. That is not what it usually is with respect, not what you're usually going to do. So if it just says find the rate of change, then it means dB dt, and this would become 3s squared times ds dt. So if anybody said, just if any of the questions just say find the rate of change, they mean with respect to time. Okay, so the assignment is kind of a mix of things. It's about reading and putting into practice all of the little things that we've said. I haven't actually shown you how to do a lot of the actual problems. I've more just given you the information you need to solve those problems.